Let's begin our third presentation of this module where we look into the production data, both the flows and how they become calculated as shares. So at this point, we've uncovered the fact that these equations that we've looked at have mostly percentage change variables in there, meaning they're measuring proportionate changes from something. So we need to know where the data is that the the data representing the initial equilibrium, so that we can understand what these changes are. And so a good place are these STC shares, or shares in total cost, and that's something that we're going to try to look into. So this is that zero profits equation that we ended last session on. So the equation QO, remember, this zero profits is determining industry output. If you read the note here, it says EQ0 defines zero profits. Condition permits us to determine the endogenous output level for each sector. Only when profit slack is itself endogenous are we not able to. And remember, that is that slack variable that we're leaving. We'll learn about when to use those and what they're for later. Let's remind ourselves this equation is a share-weighted input price index. So on the right-hand side, you have all the inputs being pre-multiplied, their percentage changes being pre-multiplied by their shares in total cost, and that's equated to the output price, or the unit cost, on the left-hand side. Now, this output price index being made of share-weighted changes in all of the inputs is something that gets repeated as we move through all the production nests. So you'll see that the average cost, or the unit cost, of making a value-added composite good must be built from the share-weighted cost of all the inputs in the value-added nest. That means a different set of shares, right? Because the value-added price index aggregates up into the sector output nest, right? And so we'll need shares there. When we look at our intermediate composite, we'll need a different set of shares. And so that's what we're going to spend our time on in this lab, lecture, demonstration, session, whatever you want to call it. Let's get a look at both of those those second level production nests in terms of what those look like. So again, I'm trying to clip the equation numbers so that you can find those if you want to just scroll through the code, find the line number, and verify these equations. This is the price of intermediates equation. The shares here are going to be intermediate shares. That means when you get to the intermediate composite good, it'll have its own cost, and take all of the individual intermediates, their share in that component cost, and just the intermediate composites cost, and use those to get the share weighted price for the intermediate. Same thing happens when we go with the value added. Here we'll call it the value added share, and those are the shares of primary factors, cost shares of primary factors, in creating the value added composite input that travels forward into the upper level nest. I do just want to note, put a note here to remind myself that value added inputs are from the set in E and DW, and so we see the summation here over the index E, the controlling set E and DW, and so everywhere here you see these E's. That represents an element of the set of endowments, the primary factors, distinguished from the commodities indexed with a C in this set. So the GTAP notation here says, take a sum over the index C, where the C draws elements from COMM. Okay, so in those equations, the shares are the data. In the production module, um, the way we're going to find GTAP data from the database is through the parameters, which we'll leave for the next session, or through shares. And so it must be the case if this, either the shares are written in the GTAP database or they're derived from value flows in the GTAP database, and the latter is the case. So in the linearization of these CES equations, the shares represent the initial, and of course they would also be updated, equilibrium flow data. And so it must be the case that when we see something like STC, the share in total cost, we could go and find its definition in the code and essentially take on the investigator role of digging down until we find what components make up STC. How is that getting calculated? What is that, the derivation in terms of data? Because we may want to go and look at the data that is coming into the model, do some comparisons across sectors, across in terms of the cost structure, or across regions. In any event, we'll have a few lectures later in this or in this phase of the course, but also when you visit with instructors, where they talk about being a good modeler and being familiar with the data and having a good handle on it. And so it's why we go through this process every module. We spend some time on theory, we spend some time sort of digging around the code, then we try to use the code to point us to data pieces that are informative, and then of course we end with simulation to examine how it all comes together and how we might conduct analysis. I just want to hit on this notion of updating. So we talked about it in Module 1. GEMPACK solves the linearized model, but it solves it in small steps. And so that means GEMPACK, you tell it some shock that you want that's 10%. It breaks down that shock into 0.25% or 2.5%, shocks that, and solves the model in a first iteration, moving a small amount of the path for the shock, and then it goes in and updates all of the value flows that are deemed updatable, and we'll see that when we get into the data. Updates those so that you're getting revised cost shares to project forward from. And that's how it is the case that you can trace a nonlinear path with a linearized solution algorithm. So that updating statement, updating the shares so that you're not just projecting from the initial shares, is what's important. And then it's the nonlinearity of the solution. We're going to search for something called STC open parenthesis in just a minute, but I do want to note something that's going on here when we get to that equation. So I've already picked out, I've already found in my GTAP v7.tab the share total cost, and you can see it's in line 1034. But I just wanted to note that the definition for share of total cost is written over a controlling set called DEMD. So it takes an index of D. So instead of ENDW or COMM, which is what we've seen so far for the used with STC, this one takes on something called DEMD, or the derived demand commodities, derived demand inputs. So DEMD is a superset that is the union of endowments and commodities. So it's everything that a firm might have a derived demand equation for. And that's useful because it means we can write a single equation, a single coefficient here and a single formula operating over that larger superset and calculate all the shares and total costs in one formula. So we don't need to write a second formula where the first one was over ENDW and the second one was using the set COMM. And over here I've shown up in line 146, and in that entire neighborhood of the code in GTAP v7.tab, you'll see the set definitions and how they combine or union to make some other useful sets. So commodities, endowments make up the derived demand inputs in production. Okay, so I'm going to open this, but we're going to find out that the formula for STC takes on the ratio of something called VFP and VOS. And so now I'm going to open my Tableau code. You can do the same, and we'll go through this process together. Okay, I have run GTAP open. Remember, we have this splash page, the title, the version, and that's where we want to check and see what version we have open. This is the 3x3 GTAP course aggregation, but what we're really checking for is this name, this short name for the version, NCORS 3x3. If you don't have that one loaded when you open your Run GTAP, go to version, go to change, scroll down, select in course 3x3, and click OK. And that should bring this up for you. There's some more information here. You can see what we're using an old database. It's a teaching database, version 4, and we use it because it's the one that was used to write a lot of the documentation for training. Okay, so we have the simulation material or tabs over here, but we're going to look in the code, right? We were left off from the slides thinking about STC. So let's go to View, Tab Files, Main Model. And now I said I wanted to search for something called capital STC, and then I'm just going to use an open parentheses. And hopefully that'll get us somewhere close to what we're looking for, that definition for STC. Okay, I'm going to go ahead and close and just scroll a little bit here. And you see this is the part that I snipped out, line 1034. So the coefficient STC is the share definition. You see some zero divides here, just basically telling Genpack what to do in the processing of this if it comes along into a zero divided situation that is not expected. And then here we have that formula. So the formula says VFP divided by VOS, and then the zero divide is turned off so that the default behavior for the occurrence of a zero divide is turned back on. That's, again, an advanced topic that we can leave alone. Just trust the GTAP coders for right now. Okay, so what we want to do now is dig further. We found STC. It has these two data pieces, VFP and VOS. Now, I don't know what those are, but I know I'm in the place where I can find that out. I'm under the impression that this is going to be something like the value of a factor of production. It is indexed over the derived demands by activity by sector, and this is only by sector, and I know it's got to be a share, so this must be the value of output, maybe at supplier prices or something like that. So, but what we would do, or what we might think of doing, is searching for VFP, but I want us to learn a new technique, and if you look at the next slide in the slideshow, you would see exactly what I'm getting ready to do. You could highlight this text here, or you could just place your cursor, as long as it's in the interior of the name of this coefficient, VFP, and then just go up here to the top, and you see all these. Some things work, some don't. So here's the open, the reload, the print. I want to go all the way over to this G that says gloss. And so gloss is a feature that's built in where if you click it, it'll show you all the instances of the currently selected coefficient or variable or you know, anything in the code, if you're highlighting on it and it has multiple instances, then Gloss is going to print for you, or sorry, display for you a page. And so let's look at that. I'm going to click Gloss. You can too. And so that pulled up this window all about the coefficient VFP. Now I don't like how narrow it is. And you can see that the text isn't filling out to fit it. So I'm going to go ahead and close it, spread it out, close it, and then maybe it'll look better when I click Gloss the second time. And it does. So if you had that same problem, that is your solution. To spread out use the arrows to expand this, and then close and reload it, and that'll be the new default size for the Gloss window. Okay, so you see here that the Gloss is giving me statements that mention VFP. So there's and that's a coefficient. Here's where the coefficient's defined. We've already found that one. Here's a formula for VFP, and it says that VFP is equal to EVFP in line 613. And so the beauty of Gloss is I can get, if I find the first thing I'm interested in and I need to keep working my way through it. So I found share of total cost led me down to VFP. Now I've glossed on VFP for all the possible instances, and I've actually found a formula here that says VFP is equal to EVFP. I found a second formula right underneath it that says VFP is equal to VDFP plus VMFP. Okay, so over here's the line numbers, 613 and 615, they're right next to each other. So that means if I go to one, I'll be seeing the other one. And of course, Gloss has hyperlink, so if I click on the 613 in red, it'll take me in Tableau, move my cursor to this new location. So I clicked on it and I get those two formulas. So the first one, let's look at the construction here. The coefficient VFP is over that set derived demands. Okay, so everything that could be an input, these derived demands for a firm, is how the coefficient's defined, but the coefficient is built from two formulas. So the first part of the superset demand, DEMD, is the endowments. The second part is the commodities, COMM. And so that means that you can take a coefficient defined over the superset and fill it with formulas, first using the endowments, second using the commodities. And so here we have EVFP, VDFP, VMFP as the three things that define VFP. Okay, we can continue to look at that, and we could go to something like EVFP. Remember, we're trying to find data, something from the database. So we're going to keep going until we see something's either being read from the GTAP database or we find a formula that leads us into some other coefficients. I believe we're at the bottom here, but let's check. So I've got my cursor set into EVFP. I click on Gloss, and sure enough, the top one here says coefficient EVFP. This is the definition for EVFP. It's the expenditure on endowment, E, by sector A in region R at producer prices. And then the next line says read EVFP from the file GTAP data. And we know from the previous module that that's the database. The next line says update. And so this is one of those coefficients that when the model solutions, right, when it's doing the steps of the model solution, the linearized steps, this is one of the coefficients that gets updated, and the variables that update it, the percentage change in the price of an endowment, the percentage change in the quantity of an endowment. Okay, and remember that from last week we looked at these update statements just a little bit and said the multiplication here is just a GTAP notation. It is not an actual operation that's happening. GTAP needs to know what all are the components in levels terms that should be used, and so it's taking these two percentage change equation variables and saying that would be the update. Now, GTAP is actually very smart, and it not only gave me EVFP, but it saw that VFP was the last thing I looked at, and so it's holding those down here for me too, the last gloss I did. And so it is letting me sort of log my work. If I have to backtrack, the last thing I did is right there. And so that's what that dashed line there represents. Okay, I'm going to go to line 331. And I see that this has to be read from the database. And in fact, if we look, we saw that VDFP and VDMP both had to be read from the database, so we can find those as well. And so that means we're going to go out, we're going to open our GTAP data file and look at these values. So what does that mean for me? I'm going to minimize my tab mate and get back to run GTAP. Right, so this is my welcome to run GTAP. I'm in the version page here. And we can go to view base data if we want to look at the GTAP base data and go to core data. That should open for you view har. And now we would look for the different things that we just said. So in section 3, we have EVFP. In 8, we have VDFP, and in 17, we have VMFP. Now, we have some different ones here, and so we won't get to these until a later module when we are talking about producer prices, basic prices. And that's where the policy comes in, right? So net of taxes and subsidies, the basic price is sort of the equilibrium price in the market. The producer price will be different from that by whatever policies are in place that could cause those differences. And you can just see here that there are some policies causing the basic price and producer price to be different, both for the domestic and for the imports down here in 17 and 18. Okay, let's click on one of these headers and open it up. And so let's look at what we have. I want to focus on Sub-Saharan Africa. So if you click that, it gives you the little warning to remind you that you either need a summation or pick an individual region, while the other toggles over here are set to show all, because you're using up all your dimensions there. So you can only have one from that point forward. And so what do we have here? Well, we have the use of land, unskilled labor, skilled labor, capital, and natural resources in the production of food. So as you move down the food value of output, right, you would expect to see this cost or this amount covered by land, this amount unskilled labor. These are the payments for these factors. Now, the problem we have, if we were trying to think about how to replicate or do a calculation of that share of total cost using the data, this is only over part of the derived demand inputs. This is only over the endowments. And so even if we were focusing on food, to drill this down and started thinking about shares, we're only getting shares in the value added. We're getting not the right share that we were trying to work from. And so remember that VFP, that coefficient, combine this, the endowment, the values in 8, and we can select food there. And so these are the payments for inputs from the food, right? So intermediates provided from food production, from manufacturers production, from services production, purchased by the food sector to make food, right? So it's the own input case here, which is quite large in food production because this is a large aggregate. It has all of agriculture and food mixed together. And so the food sector obviously buys a lot of its own output for use in making other making its output, because it's mixing in crops, it's mixing in livestock with meat, bread, and other things. But the key point we're trying to get at is you have these domestic intermediates, which also comprise part of the cost, and then of course we could go down there to VMFP and 17 and see that there's the import intermediates that we have to account for in the cost. So we can't reproduce the share of total cost here unless we want to get a spreadsheet open, copy some of these things over. But you'll remember sometimes the core data is useful for the GTAP model. It's a useful way to construct things, and you can see why. So VDFP versus VDFB, well, that gives you a very clear idea of where the policy is, right? And that's going to be a different policy. The tax or subsidy applied to primary factors is going to be a different variable, a different tax variable than you might see in 8 versus 9, the producer price versus basic price for intermediates. And so while GTAP builds up the coefficients it needs from these core data pieces, they're not as handy for us to look at. But we talked in Module 1 about another way to represent the data, and we went to View, Base Data, GTAP View Output. And so if you open that header array file and start reading what we have here, last week we looked at GDP from the expenditure side when we were doing hands-on computing. But if we moved on down here, we might find some things that are interesting to us, and one of those would be in line 15 or element 15, the cost structure of firms. So VFP, the thing that GTAP is using in the model to calculate the share in total cost, is also calculated by this GTAP view file to give us these useful ways of viewing derivatives of the base data. So the base data comes in as these core value flows. Things get calculated, things get adjusted as we do the model solution. But you can always go and find something like the output disposition, the GDP, the capital account, or indeed the thing we've been working on, the cost structure of firms here in GTAP View. And that's something that gets updated. So if you solve the model and you want to go check the new cost structure for the firms, you go to the updated version of GTAP View. Okay, so I clicked on it, and now you see that we actually do have all of the derived demand inputs down here defining the rows, and over here we have the activities. So let's go through this. We do want that to be all. We're going to click on all here and just take the food sector. Instead of being summed over the regions, we're going to take Sub-Saharan Africa. This is giving us either a breakout on domestic versus imported inputs, or we can leave them summed, and I'm going to sum them. And then here we have the the purchase value, so the base price or the tax. So if you want to know what component is base price, basic prices, and what component is taxation upon it, you can get that too. We're going to leave it at the full purchase value since we're trying to get the ordinary cost structure, and we can put this back to all activities now. Oh, sorry. I want the last one to be sum over the purchase value. I want this to be all activities in sub-Saharan Africa. And so here you have it. Here you have that cost structure for all of those firms. And so a natural thing to do would be to take, for the food sector in sub-Saharan Africa, what is the share, 6052, over the total? And that would be your cost share. Now, these values are all in millions of US dollars. So it's an important thing for us to keep in mind. I'll try to keep reminding us every time we open the database when we look at a value flow, at least for a good while. So these are in millions of dollars, but GTAP's using the share, so we want to calculate the share. And again, the temptation is to open a spreadsheet, but the people at GenPack who program ViewHar, they have those temptations too, and so what they did was they built in a share calculator. And so what we can do is go to this box, this toggle box, and instead of having no special view or no share view of the data, we could take column shares. And so now if you move down a column, you're not getting the value flows, you're getting each individual cell over the total. And so these are those shares in total cost. And so you can see food, in the production of food, is a big component of the cost. Unskilled labor is the other big component. And just like, for these very aggregate sectors, you're always going to find the production of that sector being very important in the total costs. And so here it is, the largest item, unskilled labor, skilled labor, capital. So the value added versus intermediates in manufactured production in sub-Saharan Africa, back in version 4 data, and then here in the production of services. Some things to note: land is only used in food. There's no cost structure, no cost share for manufacturers or services. That is a universal feature of GTAP. European Union, Sub-Saharan Africa, any region that you build from the GTAP database, land will only be used in agricultural sectors. The food sector here brings in the agriculture as part of its aggregation, and so it is those costs that are in there in the primary agricultural production that are causing food to have this cost share for land. And then natural resources are only used in some sectors as well that have been aggregated into manufacturers here. So what does that mean? Well, you may see a price of land reported for manufacturers, and that would just be an artifact of the equilibrium process, because the actual contribution to cost in manufacturers has to be zero. The price for land can go up, go down. It won't affect any price indexes in the production tree for manufacturers. Okay, ready to move forward. I'm back in the slideshow. If you go back through the last 2 or 3 slides we were actually doing, I just have the notes there in the slides that we skipped over in this presentation because I was doing all the steps on the video. Going forward, on your own, I would suggest repeating the steps we just did so that you get the cost shares for the value added aggregate. So that means going in, looking up that VA share, finding out how it's calculated, working all the way till you find a read from the database, and then going and doing that. And I believe if you paid attention to what we were just doing, we almost calculated that share, right? So you can do that one in the core data file because that operates over the endowment set, and the core data actually does read in EVFP, so you can find those shares there. As we continue into our last session for this module, we're going to learn a better way to evaluate components of the data. So I like going and opening the database. Practically though, when we're doing analysis later on, we're going to have to learn to be able to quickly access the shares or the sort of value flows that are determinant in components of our solution. And so it turns out GenPack has a good way of doing that as well. And we'll also cover the last data item we haven't seen yet, the parameters. Okay, that ends our production data flows and shares discussion and demonstration. There's a review quiz that's ready for you to take. And of course, you can always email any questions you have to the contact information.